Hello everyone, I am Dr. Rajesh and I am again with you. In this video lecture, we will study a numerical problem based upon Lami's theorem. So in the last lecture, I have told you that in the next video lecture, I will be with you with the numerical problems upon the Lami's theorem. So the statement of the problem is, a particle is in equilibrium under three forces. Three forces are acting upon the particle and particle is under equilibrium under the influence of those forces. Two forces act at right angle to one another. So out of these three forces, two forces are acting right angle to one another, means 90-degree angle. One being the double the other, and out of these two forces, one is double the other. Third force has a magnitude of 10 kilogram weight. Find magnitude of other two. So the third force has magnitude 10 kilogram weight. So now let me draw the forces. Let this is one force P. This is at right angle to this force. Say this direction, double the force. This is force twice of P. This is P, say. This is twice of P because it is double, and this angle is 90-degree. We know that their resultant will act somewhere here. So that will be the resultant. But to keep these two forces in equilibrium, the third force must act in this particular direction opposite to the resultant. If I plot it over here, this would be the direction of the resultant. So the third force cannot be taken in this direction. It has specific direction, and that direction will be in this particular direction. So I am going to draw it as fine, and say this is the force. It is given 10 kilogram weight. Done. And these three forces are concurrent at point O. Fine. At this particular point they are acting, and these forces are given to be in equilibrium. So we will write, since forces are in equilibrium, therefore using Lami's theorem. So you can write over here that forces are in equilibrium. Are in equilibrium. Fine. And if the forces are in equilibrium, therefore using Lami's theorem, using Lami's theorem. Fine. So now we'll use the Lami's theorem. What does the Lami's theorem state? That if three coplanar concurrent forces are in equilibrium, then each force is proportional to the sine of the angle between the other two. So now firstly I am going to write the all three forces. Say this is force P, this is force 2P, and this is force 10 kilogram weight. Now take this one, 10 kilogram weight, sine of the angle between the P and 2P, which is 90-degree. So I am going to write it over here, sine 90-degree. Fine. Now 2P, sine of the angle between 10 and P. So this angle we suppose that is not known. So this angle is supposed to be theta. Fine. So this will be angle between P and 10 is supposed to be theta. So this will be sine theta. Now we know that this whole angle is 360 degree and out of this 90 degree is gone, so we are left with 270, and out of 270 theta is also gone, so this angle is nothing but 270 minus theta. Done. So this will be sine 270 minus theta. So this implies that P divided by minus cos theta 2P sin theta. Why minus cos theta? Sine in third quadrant is negative, and because of 270 degree over here, sine will convert to cos. So this will be 10, and sine 90 you know is nothing but 1. So now this equation could be named as equation number 1. Now taking the say first and third term of this equation number 1, what we will get? P minus cos theta is equal to 10. This implies that P minus P is equal to 10 cos theta. Now taking second and third term, we get 2P sin theta second and third is equal to 10. This implies that 2P is equal to 10 sin theta. Now we have to find P. So from this we can write it as minus P. We have to eliminate theta. Minus P by 10 is equal to cos theta. Fine. And it will be 2 to 2 will cancel out, it will be 5. So it will be P by 5 sin theta. Done. And these are named as equation number 2. This is named as equation number 3. Now we have to eliminate theta. You know that cos k theta plus sin k theta is 1. So it can easily be eliminated. So now what we will do? You will square both sides and add these two equations. So what you will get? You will get P square by 100, because square of minus P by 100 by 10 is P square by 100 minus square is positive. It will be P square by 25 is equal to cos square theta plus sin square theta. You know this thing is 1. Here P square is common, 25 is common, so 1 by 4 plus 1 is equal to 1. This implies that P square by 25 into 5 by 4 is equal to 1. This will go on 5. This implies that P square is equal to 20, implies P is equal to root 20. And you cannot take the negative, because here it will be plus minus, but negative force in magnitude cannot be negative. So we have rejected the negative sign. So we have taken the positive, and units will be same as given that of the third force, that is kilogram weight. So one force is P, which is root 20 kilogram weight. And you know another force is 2P. Fine. And P you know is root 20 kilogram weight. Fine. So 2P, another force, will be 2 root 20 kilogram weight. Fine. So this force comes out to be root 20 kilogram weight, which we were required to determine, and this comes out to be 2 root 20 kilogram weight. So these two forces were required to determine, and this problem is based upon the application of Lami's theorem, and this theorem is important theorem. So I hope that you will be able to understand that how we apply the Lami's theorem, and when the force is 3 forces. The Lami's theorem will be applied only when 3 forces are given, and those 3 forces are concurrent and coplanar. You must remember, if 4 forces are given, you cannot apply the Lami's theorem upon the 4 forces. So you need 3 forces to apply the Lami's theorem. So you must give attention to this fact, that you must be given 3 concurrent points, concurrent forces, and those forces should be coplanar. Only then you can apply the Lami's theorem. So in this case we have applied the Lami's theorem. So this was the problem based upon Lami's theorem. So this is all I have from this lecture, and I hope that you will be able to understand this lecture, and very soon I will be with you with my next video lecture. In that video lecture we will study some more problems based upon Lami's theorem. So till then, take care, bye bye, and see you soon. Thank you very much.